Welcome back to our first day of Unit 3. So today, our day 1 goal, given a quadratic function, you will be able to correctly graph it and, with the assistance of your calculator, find the minimum or maximum. So today, we're going to be graphing our quadratic functions using our calculators, okay, and finding a minimum and a maximum. All right, so let's make sure that you definitely have your calculator handy. All right, and your note packet. So let's go ahead and flip to our day 1 notes. All right, well first, let's talk a little bit about, well, what is a quadratic function? Well, a quadratic function, a quadratic, is actually just a fancy way for saying it's going to be a parabola when you graph it. So here's our important information. So given a quadratic, okay, the standard form of a quadratic is going to be y equals ax squared plus bx plus c. And a, b, and c are just numbers. Okay, so let's go ahead and take a look at our different parabolas. So if we look over here, this parabola, I like to call that a happy parabola. It's concave up. All right, it's smiling. If you give it two little eyes, it's smiling. And if we take a look, its formula is ax squared plus bx plus c. All right, if I take a look down here, this parabola is what we call concave down. It's going downwards, opening downwards. And if I put my eyeballs here, it's actually a frowning parabola. And this is the function y equals negative ax squared plus bx plus c. So if your a value is positive, so here's the positive, that means it's going to open upwards. Okay, and if your a value is negative, it's going to open downwards. Okay, in addition to this, let's take a look at the turning point. Okay, so the turning point would be this point right here and this point right here, because here the function is decreasing and then here it changes and now it is increasing. So this is called your vertex, your turning point. And if I look, this is on the bottom of the graph, which means this here is going to be a minimum. It's the lowest point on the graph. So minimum. And if I look here, this point here, your turning point, it's at the very top of the graph. So this is what we would call a maximum. Okay, next, let's talk about the axis of symmetry. So if you think back to elementary school and you had to draw pictures with symmetry, symmetry means it's the same on the right as it is on the left. So if we take a look here, do parabolas have symmetry? Well, yes, they do. It would be the line going straight through the middle of our parabola. So this would be your axis of symmetry. It goes right through the middle, and its equation is x equals, and there's a formula, it's negative b, which we always put in parentheses, all over 2a. So negative b all over 2a. Okay, now the turning point, well, we already talked about that. The turning point is the minimum or the maximum, and it's where you change direction. So here we go down, we change, and now we're going up. Here we're going up at the turning point, now we're going to go down. So some alternative names for the turning point. It could also be called the vertex, the minimum, or the maximum. Okay, your domain, remember domains are the x values that we're going to use when we're graphing. Okay, so let's go ahead now, let's put this all together and let's practice graphing our parabolas. Okay, so here we have in the box, we have our steps for graphing. So graph and label the function f of x equals negative x squared minus 3. Remember, f of x is just a fancy way of saying y equals. All right, so the first thing we need to do is determine what is our a value, our b value, and our c value. Okay, so if we remember, the a value is in front of the x squared. So here it actually is a negative 1 is our a. My b value, so if we look up here, the b is right in front of the x. Now if I look at my equation, is there an x? There's no x. So if there's no x, what number represents nothing? Well, that would be 0. And my c value is -3. Okay, so the first thing we have to do is find the axes of symmetry. So my axis of symmetry is x equals -b all over 2a. So that's going to be -0 all over 2 times -1. Well, 0, we can't really negate it, so it's 0 over -2, which then equals 0. Okay, now the reason we find this axis of symmetry is because that's the exact middle of our parabola. So what we're going to do next is we're going to create a table of values. So we're going to go x and y, and we're going to take our vertex and we're going to put it, or our axis of symmetry, and we're going to put it smack dab in the middle. Now we want to do at least 3 values above and 3 values below 0 now for our table, for our domain. So I'm going to go -1, -2, -3. 1, 2, and 3. Now, to find the range, I am going to let the calculator do the work. So I'm going to go to y equals. I'm going to clear everything out, and I'm going to type in my equation, -x² - 3. And now I'm going to go to my table of values, and I want to match up my domains to find the corresponding y values. So -12, -7, -4, -3, -4, -7, -12. Okay, so next step, plot your points. So -3, 12, well, that's not going to fit on my graph, so that's okay. I just won't plot those. So -2, -7, -1, -4, 0, -3, and then it goes back down. Now we're going to sketch this. Now just like when we sketch lines, we carry it all the way to the edge of the graph. So I'm just going to go all the way below. And then at one of the arrows, we're going to label. Oops, so let me bring that down here. So now we see it all. So we plotted it, we graphed it, we labeled it. So now it says, what is the turning point? Well, the turning point is the vertex, and it's the point right there at the top. So this is going to be the point 0, -3. Now, what do you notice about the turning point and the middle of our table of values? Well, this is also your turning point or your vertex. So it's the middle in the middle. Is the turning point a maximum or a minimum? Well, it's at the top of the parabola, so it would be a maximum. And what is the equation of the line of symmetry? We found that up here. Our axes of symmetry, our line of symmetry is x equals 0. And x equals 0 would be the y-axis. So this would be our axis of symmetry going right through the middle. All right, we've just graphed our first quadratic. So let's go ahead, let's flip it over, and let's try one more. Now, if we take a look at this one, it's written a little bit differently. We have y equals x minus 1 squared plus 2. So our x is being squared, but the square is on the outside of the parentheses. So I'm going to have to do a little work here to get this in the correct form. So this is actually what we call vertex form. So we know that when we square parentheses, we have to write it out twice. So I'm going to go ahead, and this is actually y equals x minus 1 plus 2. So now I'm going to have to go ahead and use my long distribution here. So x times x, x squared. X times -1 minus x. At -1 times x minus x. -1 times -1 is plus 1. And then I'm going to bring down that positive 2. So this is y equals. So now I get y equals, let's combine our like terms, x squared minus 2x plus 3. So here's the equation of my quadratic. So my x is being squared. So now it's pretty easy for me to see my a, my b, and my c. So my a value is going to be 1. My b value is going to be -2. and my C value is going to be 3. So now the first thing we have to do is find our axis of symmetry. So x equals negative b all over 2a. So when we plug it in, we get a negative 2 all over 2 times 1. And a negative 2, well, that becomes a positive 2 over 2, which then gives you x equals 1. So now I can write my table of values. And I'm going to put 1 in the middle, because that's my axis of symmetry. It goes in the middle, and I go 3 values below and 3 values above. And then we're going to let the calculator do the work. So at this point, I'm going to stop you where you are, and I'd like you to finish this on your own. Okay, and at the very end, I'd like you to type in what the turning point is. All right, let's go ahead and take a look. So if you filled out your table and you plotted your parabola, you can see that the turning point is 1, 2. It's a minimum, and your axis of symmetry is x equals 1. Okay, what I'd like to do now is I'd like us to find out how we can find our turning point without having to set up a table of values or graphing. And we're going to do that by using just the calculator. Okay, so we're going to follow these steps through the first question here. So I'd like everybody to go to their y equals and type in the first equation. Okay, then step 2, we're going to hit graph. Okay, we're taking a look at this graph, and we need to decide, is it a minimum or a maximum? And here my turning point's at the bottom, it's a minimum. So now we're going to hit second trace. So second trace. And now I can see I have the word minimum. So I'm going to hit 3. And now I'm going to use the side-to-side arrows and follow the directions. So right now it says left bound. And if I look at my blinking dot, it is on the left of my turning point. So I hit enter. Now it says right bound. So I'm going to move over to the right of the turning point. Now I'm on the right. I hit enter. Now it says guess. So I'm going to go back towards the middle. Now I'm right on that turning point. I hit enter. Now there's no more question marks, and it gives me the minimum. Now my minimum here, it has 1.499999. The pixels in your screen can sometimes get a little funky, so they're not going to be perfect. However, 1.499999, that is supposed to be 1.5 and then 0.5. Okay, what I'd like you to do next is try question 4 completely on your own. All right, let's take a look. Were you able to round to the nearest tenth to get 0.3 and 3.7? Okay, there's one more skill I'd like us to try, so let's go ahead and flip to the next. Okay, so here we go. Next, we're going to have to learn how to change our window to see the entire graph. So we're going to follow these steps after we read through question 5. So a baseball player throws a ball from the outfield towards home plate. The ball's height above the ground is modeled by this equation, where y represents the height in feet and x represents the time in seconds. What is the maximum height the ball reaches? So let's go ahead, take our calculators, and let's type in our equation. Okay, now let's hit graph. Okay, so I can't really see my parabola, but let's think for a second. If this is a baseball player, I'm sure he's throwing the ball higher than 10 feet in the air, and our graph only goes to 10. So we're going to have to increase the maximum height. So to do this, we're going to hit what we call the window key. Now here it tells us how far left, right, and up and down we're going. Now we need to increase the height. So we're going to go to the Y max because our ball is going to go higher than 10 feet. I'm going to type in 50. Let's see if we get it. So then we hit graph. All right, now I can see the top of my parabola. And at this point, to find the maximum height, now I can do that. So remember, maximum, we're going to hit second, calculate, and then go down to 4, which is maximum. Okay, I'm going to hit enter for the left, go over, hit enter for the right, go to the middle and hit enter for the middle, and there we go. My maximum was 1.5 comma 42, so we have to remember which one of those is the maximum for height. 42. So 42 feet would be the maximum height, and we've got it. Have a great day, everybody.